Hello, this lesson is in your Big Ideas textbook and it is section 5.4, and we are going to be not only comparing ratios, but we'll also be graphing from a ratio table, if you remember how to graph in the coordinate plane. And so this question is deciding which mixture is hotter. So you're making a mix of salsa, and you have salsa and you're adding some hot sauce to it. And so I'm going to call this mixture 1, and I'll do it in blue. And mixture 1 has 8 tablespoons of hot sauce and 3 cups of salsa. And mixture 2, a little bit different, starts out with 12 tablespoons of hot sauce and 4 cups of salsa. And now you have to figure out which is hotter. And so remember that we looked at unit rates and we looked at common quantities. And so this is one that a kind of question that seems that you might want to make the salsa the same because it's the hot sauce that changes everything, right? So let's go ahead and think about, if I look at the 3 and the 4, I'm already thinking that 3 times 4 is 12, and 12 is the common multiple of 3 and 4. But first, I'm going to go ahead and fill out the table of what if I just do this? I'm thinking of 12, but what if I multiply by 2? So I'm doubling this recipe, right? And then I get 16 because I multiplied by 2. And then, oh, this works. I can multiply by 2 again, and I get 12, and I multiply by 2. So remember, we're just creating equivalent ratios using a multiplication pattern. And whatever you multiply the bottom by, you have to multiply the top, or the other way around. And so now when I get to the mixture 2, maybe I will also double the recipe. And when I double the recipe, I have 8 cups of salsa and I have 24 tablespoons of hot sauce. And then I know that I wanted to get to my common multiple of 12. So I'm going to go ahead and skip the middle row and go straight from 4 times 3 is 12. So then I go back to the 12 times 3 and I get 36. Okay, so now that I made a common, right? So now I have a common multiple of 12. Now I can look at my overall hot sauce, right? Because the salsa isn't what makes it hot. It's this, it's the me adding the hot sauce. So the mixture 1 has 32 tablespoons of hot sauce and mixture 2 has 36, right? Because I kept the same ratio of hot sauce to salsa. So we can see that mixture 2 is hotter. Now I'm going to have you look at it a different way. And let's say we're going to graph this. And this is going to be my mixture 2. And this is going to be a ratio table for my mixture 1. And I have to decide, right, this is the x-axis, this is the y-axis. It really, the x is called the independent variable, and this is the one that you change, and then the y depends on the x. And so how spicy the mixture is really does depend on how much hot sauce you add. So what I might do is I might make the hot sauce. So down here on the x-axis, this is going to be the hot sauce. You know what? I'm going to make this black. Sorry. Let's just go ahead and label the axis black. All right, so the x-axis is going to be my hot sauce, and my y-axis is going to be my cups of salsa. Right, and this was actually tablespoon of hot sauce. And then I'm going to go ahead and put the numbers from the other page into the tables here. So mixture 2 was 12 and 4 and 24 and 8 and 36 and 12. And mixture 1 was not as hot, but it was 8 and 3, 16 and 6 and 32. Okay, so now I've got my values, right? So this is what we did in our ratio table. I just turned it into an X and a Y. And the X stands for the hot sauce and the Y stands for the salsa. So now I've labeled everything that I think I need to label, and I can just start graphing. If you remember how to graph, you start at the axis the place where the x and the y axes meet is at 0. And wait a minute, oh, I don't have any numbers on my graph. Well, I need to add some numbers. Now, here's the thing. The scale that I put on the x-axis doesn't have to match the y. In fact, when I look at this x, look how high it goes up to. It goes up to 36. But notice the y only goes up to 12, just in these numbers that we have. So what I'm thinking of doing is counting by twos. So I could do this. 2, 4, 6, 8, 10, 12, 14. I'm going to pause this and keep numbering. Okay, so notice I went from 2 to 36, and notice that my numbers are right on the line, right? Because when we plot points in the coordinate plane, right, this is called a coordinate graph, coordinate plane, I want to make sure that the 32, wherever the 32 is, I go straight up that line, right? I'm not putting the numbers in the spaces in between, they go right on the lines. And then I need to do my cups of salsa. Okay, because my cups of salsa only went up to 12, I was able to count by ones. So now I'm going to start with mixture 1. The values that I'm trying to plot on my graph are 8, 3. So I think about this is my first number, this is my second number. So I start at the 0 and I go over 8 and up 3. Remember, we do the x first and then we go up and we plot our first point. And then I go 16, 6. So I go all the way over to 16 and I go up 6. And then the last one was 32, 12, all the way over here at 32. And I have to, sometimes this one's a little bit harder. Oh, 12 there, there's my 12. Okay, so now that I have those 3 points, now I can make a line. And I'm going to make a line like this. Oops, I didn't want my arrow going down. All right, actually, I need the other color. Let's put blue. All right, and notice that my line, oh, guess what? Lines go on forever, so I don't actually have to stop there, but I do need to try to go through all those points. Okay, so this is the line that represents my mixture of how many tablespoons of hot sauce along with how many cups of salsa. That's for mixture 1. Now I'm going to do the same thing for mixture 2. I'm going to plot 12, 4 right there, and then 24, 8 right there. And then the last one is 36, 12, 36. That matches that one. Okay, and then I'm going to connect those points starting at 0. And I try to go through the red. Okay, so there it is. Now, when I look at my graph, well, I remember that the mixture 2 was hotter because it had 4. And so really what I can focus on right here is this point. Oops, I want purple on that. This point here and this point here. This is the 12, right? So 12 cups of salsa, and this has 32 and 36. So I can see, I'm going to make a face here. There's a difference of 4 tablespoons. So notice that mixture 2 has 4 more tablespoons. It goes further to the right, which is the x-axis, right? It goes along the x-axis and it goes farther. And so I can see, based on my graph, even though the red line is underneath the blue line, it is hotter because it reaches further to the right. So I can see, looking at this graph, that mixture 2 is hotter. Mix 2 is hotter. Right, so it goes further to the right. Okay, that's the first example. All right, and then of course I want you to think about, pause the video and think about some ways that we have been learning how to compare ratios. I'll show you. Right, so we like to find something in common. We can use unit rate, we can make a graph, we can make a table, and then I want you to write this down. To compare ratios, find a common quantity with same number and unit. And then after that, if you want to graph it, that's awesome. If you want to find the unit rate, you can do that as well. Okay, so now this is the first OYO. I'm going to set it up and then I want you to pause it and try this on your own. The information is, there's this person named Andy, and Andy did, whoa, that's not what I meant to do. Andy did 120 jumping jacks in 10 minutes. And then there is another person named Bobby, and Bobby did 140 jumping jacks in 10 minutes. And the question is, which person had the greater jumping jack rate? So remember, we can find common quantities, we can find unit rates. We've got lots of different options. And I gave you some tables, and I'm just going to tell you that usually the time when you are looking at some event that's happening over time, time is the independent variable, because if you have more time, and I usually do this, I put time and then I put, like, if it's minutes or seconds or hours in parentheses. And then the dependent variable, which I'm going to do on the y-axis, is the number of jumping jacks. Okay, and then it's asking you to use ratio tables. So I'm just going to label the tables. This is A for Andy, this is B for Bobby. And then I'm going to say, I'm doing time here and the number of jump jacks here. I usually put my independent variable first. That's the way you'll see it in the real world. Okay, so I've got everything labeled except for I didn't have my units of units. There we go. And so you should start putting information in the tables and I will show you mine. So I start with Andy with 10 and 2, and then Bobby starts with 14 and 140. Oops, that's not 10 and 2. It was 10 and 120. That was wrong on this one. Not that seems weird. Okay, so once you have a table, right, remember that you're looking for a unit rate or some common, something to be in common. And one of the things that I think of when I look at this is I look at the amount of time that they're going to be doing jumping jacks for. And I kind of wish the time was the same. To make the time the same, they're both even numbers, which means they're divisible by 2, which means I don't want to divide by 2. I want to divide by the other divisor that gives me 2 as a quotient. So when I work backwards, 10 divided by 2 is 5. So the idea is I'm going to divide 10 by 5 so that I end up with 2 minutes for my time, which means I also have to divide that 120 by 5, and I get 24. And then on Bobby's side, I know that I want 2 to be here because I'm trying to get the same time. So that means I'm going to divide by 7. And if I divide this number by 7, I get 20. So I made a common time. So now I can compare easily the number of jumping jacks, right? So I made 2 and 2, and then I just, excuse me, look at the total value for, hey, guess what? Bobby does 20 jumping jacks in 2 minutes, and Andy does 24 jumping jacks in 2 minutes. So I would say that Andy has a greater rate. Andy's jumping, I'll just do jump jack, rate is greater because in 2 minutes, I don't know if it's a boy or a girl, he, she can do 24. Can do 24 jump jacks, which is 4 more than Bobby, right? Because Bobby's at 20. Okay. All right, and now this is again where I'm going to get you to practice some graphing. So I'm going to make, let's see again what colors I used. Okay, so Andy is blue and Bobby is red. So Andy is blue, so this is going to be Andy. And this is minutes, and these are jacks. And Andy's times were 10, 1, 20. And then I just decided to add another row, and I divided by 2 just to make a third point to graph, because sometimes just having 2 points is not enough information. And then this is Bobby, and there's minutes. And this is going to be the number of jumping jacks. So it started off with 14 and 140. And then at the bottom, we got down to 2 and 20. So I just decided to divide the 14 and the 140 in half to add a middle column to our table. Okay, so now here's the thing. We have made time be on the x-axis, right? So now before we can graph anything, we definitely want to label our graph. So this is going to be the x-axis, right? And this will be oops, I like to put time in the minutes in parentheses. Okay, so this is time in minutes. And that is my x-axis. And this is my y, and this is going to be the number of jumping jacks. Okay, so again, before I put numbers on my graph, I need to look at, whoa, I'm supposed to go all the way up to 140 jumping jacks. Okay, so here's my graph. I think it makes sense to maybe count by tens. So I'm going to start here, 10. I'm going to skip the 20, 30, 10, 20, 30, 40, 50. I'm just going to pause this and number it. Okay, notice that I erased my numbers and decided to go with the even numbers, because when I looked at all of my numbers, most of the numbers in the jumping jack column are even numbers ending with 0. I mean, they're all even numbers, but they're generally not the odd multiples of 10. Okay, so that's my jumping jacks. And now my time. Time only goes up to 14. So it just makes sense. I'm just going to skip the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so now I have my graph done. I can start graphing Andy's. So I remember I made my X the time. So after 10 minutes, Andy is at 120. So there's my 10 and my 120. There's my first blue dot. And then I'm going to go to 5 and 60. And 5 is right in between 4 and 6. There's 5 and 60. And then 2 and 24. This one's a little bit harder because there's 20. 30 is right there. I don't know if I'm going to do a very good job on that one, but I think that's about where it is. Okay. Now I know that if you don't jump any jumping jacks, you definitely are at 0. So I know I can start here at 0, 0, and then, oops, again. Okay, I'm going to join those. All right, and then I could, right, keep going, and let's see if they went for a longer period of time, the graph would keep going. And now I'm going to graph Bobby's. The first one is 14 all the way up to 140, which is right there. So 14, oops, 14, 140. That needs to be a point and not a line yet. There's my first point, but I'm having problems with my color. 14 and 140. There it is. And the second point is 7 and 70, which is half the time and half the jumping jack. 70 is right there. And then 2 and 20. 2 and 20. And now I'm going to make my line tool. You should use a ruler, and you're going to make a straight line going through all of those points. Okay, so now that I have this great graph made, I can start looking at it and I can go, okay, so let's see, Andy, right? This is Andy's graph, and the red line represents Bobby's. And because the number of jumping jacks is on the y-axis, right now I can tell if Andy's line is steeper, then Andy's has a greater rate of jumping jacks per minute. So I'm going to go ahead and type that in. Okay. The graph of Andy's line is steeper, so Andy has a greater rate of jumping jacks per minute. Okay, so this is one of those cool things. I don't even have to do anything else when I look at the graph, as long as I know that the number of jumping jacks is on the y-axis. Whoever is steeper is doing more jumping jacks per minute. And I can basically show you what it looks like if I grab some, look at 10. 10 isn't, well, we do have 10 minutes for Andy. If I look at 10 minutes for Bobby, it's down here at 100, right? So I go like this. I wanted to grab that purple. So after 10 minutes, Bobby is here at 100 and Andy is up here at 120. Every single point along Andy's line, except for down here at 0, is going to be higher than Bobby's. So Andy has a faster unit rate and doing more jumping jacks per minute. Okay, the next example you'll see is in your textbook, and it has to do with noticing which rises faster. There's a hot air balloon and there's a blimp, and they give you a rate, right? It's not a unit rate, but they give you a rate for the hot air balloon being 9 meters for every 3 seconds, and the blimp rises 7 meters every 2 seconds. So the first thing you're going to be asked to do is, well, can we complete a ratio table and figure out which one rises faster? So what I could do with this ratio table is I could look, if I went from 3 to 6, it's a times 2. So then I must multiply the 9 times 2 to get 18. And then if I go from 3 to 9, it's now a times 3, right? I'm going to use a different color. If I skip from the 3 to the 9, it's times 3. So then when I skip from the 9 down here, it's also times 3. So then I would get 27. And then the last one is going to be 3 times 4. There's the times 4, and I get 12. So I need to go times 4 to fill out the height. Is 9 times 4 is 36. So basically you can see this row is skip counting, column, sorry, is skip counting by 3s, and this is skip counting by 9s. So maybe for this table, I can use that same idea. If I skip count by 2s in the time, this has to skip count by 7. So it's 7, 14, 21, and 28. So if you look at the table, notice that they were pointing out that there is a common time, right? The common time is 6 seconds. After 6 seconds, the blimp is 21 meters off the ground, and the balloon is 18 feet off the ground, right? So which one rises faster? So since we found a common time, I can write in this. Let's do that one before. Every 6 seconds, the balloon rises 18 meters, and the blimp rises 21 meters. So the blimp rises faster. how I compared using a common quantity. Now I'm going to complete the graph, and well, we already know that the blimp rises faster, right? So my graph should just prove that. So I'm going to pause the video and just show you the numbers that I'm putting on the graph for the scale. Okay, so I looked at the numbers in the table and figured out that I could count by twos. Well, really just count by ones, but I'm only labeling the even numbers. And this is the time, and it's in seconds. This is the x-axis, and then the y-axis is height in meters. And so I'm going to go ahead and do the balloon in red. Okay, so I'm going to do the balloon red. Okay, so the balloon is 3 and 9. So after 3 seconds, this would be 10. There's my 3, 9. And then I have 6, 18, 9, 27. There. And really 3 points is enough to make a line, so I can go ahead and I can make my line going through there, and there's my balloon. Okay, and now I'm going to do the blimp in blue. And I start off with 2 and 7 is right there. And 4, after 4 it's up at 14, and then after 6 it is at 21. There's 22. Okay, so once I have all of my points plotted, remember I'm going through the 0. I just really need 3 points plotted. I could have done the 4th one, but let's go ahead and extend this line. Okay, I might want to make it so that the time is the same. Okay, so again, because I have the height on the y-axis, you'll notice that the higher, the steeper the line, the faster the blimp is rising, and this was the balloon. So my conclusion again is that the graph of the blimp is steeper. So the graph for the blimp is steeper and it is rising faster. So I'll say the graph of the blimp is steeper. So the blimp rises faster than the balloon. If I had put time on the y-axis, it would have been a little bit different and harder to come up with a conclusion. But because I put height on the y-axis, the steeper the line, that means it's rising faster per minute. Okay. So this is just another, showing you another way that you could have numbered your graph, but just notice that the x and the y-axis do not have to be labeled the same as long as each one is consistent. So the x is 1 space for every one, and the y here was 2 spaces, 1 space for every 2 meters. Okay, so the last OYO is looking at a weather balloon and a Mylar balloon that is rising up in the air. And so remember, sometimes you're just given a rate. It's not necessarily a unit rate. So here's the rate for the weather balloon, and here is the rate for the Mylar balloon. I'm going to move this over so you can see it a little better. And then I want you to compare with a Riccio table, and then we'll graph it on the next page. So go ahead and pick a color. I'm going to use blue for the weather balloon, which goes 2 every 16. So the time, remember I like to put the time as the independent variable, so that goes with the x. So I'm going to put the units as hours, and this unit is miles. So after 2 hours, it's 16 miles. Well, I could double it, right? Times 2, I get 4. Times 2, I get 32. And then I could make this a times 3. 2 times 3 is 6. And 16 times 3 is 48. That's for the weather balloon. And now I'll make a table for the Mylar balloon. Oops, not green, red. MB. X is still the hours, Y is the miles, and it tells me that after 6 hours, the Mylar balloon is 18 miles. Now, because the 6 and the 6, right, I already have a common time, which is great, because now I can already see that the weather balloon is rising faster. So it might make sense to put some of the values in here that match over here. So I started thinking, what if I did a, let's see, what if I took the 6 and I divided it by 3? So if I divide by 3, then I would divide by 3 over here. And then I would get 2 and 6. So the 2 is another common time. And then I thought, well, what if I multiply by 2 to get 4? So I have 3 common times. And notice the miles are very different. Okay, so now I can already see that the weather balloon, so I'm looking at my table, I look at the 6 there, I look at the 6 there, probably didn't need to go any further in the Mylar balloon table, but I'll say the weather balloon rises, rises faster because in 6 hours it will be 48 miles high, and the MB, Mylar balloon, will only be 18 miles high. Okay, so every 6 hours, the weather balloon will be 48 miles higher, and the Mylar balloon will be only 18 miles higher. That's just looking at a ratio table. Now, let's go ahead and I'm going to pause this and I'll put the information in and then show you how I'm going to graph it. Okay, so notice that the time is along the x-axis, right? So this is the x-axis, and the height is along the y-axis. And then I chose to number by 4s for the height because I had to go all the way up to 48. But on the x-axis, I skipped every other one just so I can get some numbers a little more spread out. And I only had to go up to 6 because of what we did on the hours over there. So now I'm going to go ahead and graph the points for the weather balloon. So after 2 hours, it was up at 16, and then 4 hours, it had doubled up to 32, and then after 6 hours, it was up at 48. And then I go ahead and connect those points, starting at 0, 0. There's my line for my weather balloon. Now I'm going to go ahead and do the Mylar. After 2, it was 2 is 6, which is right in between the 4 and the 8. There's 2, 6. And then 4 and 12, 4 hours, 12 miles. And the last one is 6 and 18. So there's my 6, 16, 18 is right there. Okay, now I'm going to connect that line. And now you can really see the difference, right, of how much faster the weather balloon is, right? So this is steeper. This is the weather balloon. And the bottom line represents the Mylar balloon. Okay, and what's our conclusion? We already knew it based on the table, but I'll just go ahead and type this in. The graph of the weather balloon's height is steeper. So the WB rises faster than the MB. Okay, so because height was along the y-axis, I can see that the blue line is steeper, which means, again, if I compare a common time, right, if I pick the Mylar balloon after 4 hours, it is only at 12 miles, right? Trying to actually circle. This is after 4 hours, it's at 12. And notice the weather balloon is already all the way up at 32. So steeper the line, the faster the rate. Okay, that's the end of the lesson. Good luck.